Hi everybody, welcome to Food Safety Fridays edition 120. My name's Simon Timpley from the International Food Safety and Quality Network. Today's topic is SPC, Statistical Process Control in Food Safety Management, and that's with George Howlett, the CEO of Safe Food 360. We'll be meeting with George shortly, but just a few housekeeping things. The chat bar there in the side. Some of you will be typing in already. Say hello, tell us where you're from, get to know each other, and we'll be taking questions in that chat sidebar later at the end of the presentation. Today's webinar, as always, is being recorded. You'll get a copy of the recording, the slide deck, and the certificate of attendance in an email. We'll follow up to all registrants afterwards. It's good to have you along. Just to say, this Food Safety Fridays we have sponsors who help to bring these to you each week and get you some free education, certificate of attendance. So on that note, I'm going to play you some ads from our kind sponsors. We'll be back in a couple of minutes to introduce George.
The world of food has changed a lot in the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our clients' side, shaping the future of food, today and tomorrow. AIB International, ever onward.
Just one thing to point out to you, I forgot to mention, we've compiled all of the previous Food Safety Fridays webinar recordings into an Excel so that you can keep that on your desktop and look at them at your leisure. And I've loaded that in the sidebar, that Excel, so you can download that directly from the sidebar. So there you go, a nifty little tool for you. Okay, now we'd like to introduce today's guest presenter, George Howlett, CEO of Safety 360. Hi, George. Nice to have you with us again.
Yeah, you too. Thank you.
How are you today? You good?
Yeah, all good here. Nothing to report.
No, and the weather, can you see outside?
Just the usual Irish weather, 4 seasons in one day.
Bit of drizzle, like Manchester. Yeah. Okay, well, nice to see you. Nice to have you along. Looking forward to this presentation. It's one that we've not covered before, so look to have some great engagement with the audience. So there's the PowerPoint. I'll be back for the Q&A later, but for now, I'll hand you over to George.
Okay, thank you, Simon, and welcome everybody. Just to kick off with and say that the topic of today's webinar, which is SPC, or Statistical Process Control, normally not a subject you associate with food safety management in general. Traditionally hasn't been something which many food safety practitioners would have given time or attention to. However, it is emerging as a requirement, and I suppose it is timely for us to at least take an initial look at it and get the conversation going. Before we do that, just to note that on the Safe Food 360 website, if you go to our free resources, you will find a lot of white papers, tools, and indeed presentations, which will help you to maybe get a start on some of these SPC tools which can be applied, and more about that shortly. Okay, so what exactly is Statistical Process Control, or SPC for short? Well, just a basic summary. SPC really is a set of tools or a methodology which has been used for quite some time in the manufacturing sector generally, not so much food processing, but in a more general sense across manufacturing. What it does, what it seeks to do, is to take the data which manufacturing processes generate and use it in a more productive way. So using statistical tools, analytical techniques, you can extract from that data a lot more information and insight about your processes, your manufacturing processes, and from that, implement and install controls around them. So that is definitely something that we do every day in food manufacturing, albeit most food companies wouldn't use the statistical tools and techniques that we're going to talk about today. Some benefits with SPC for companies who are looking to maybe test them and try them out. One big advantage is that it can reduce variation or variability in your process and therefore lead to a reduction in food safety failures. We'll talk a little bit more about how we can do that in a moment. It can improve productivity and reduce your costs and uncover hidden process personalities. So I'm sure you are surprised to know that your processes may have personalities, but they in fact do. And SPC is a fantastic way of revealing them and giving you insight into those processes. It can allow you to react to process changes before they cause problems. So very often, most food companies will react to a change in process once it's exceeded the limits which are desirable. But SPC can kind of give you advance notice of that, so changes can be made beforehand. One other general benefit is in relation to your decision making and identifying areas where improvements can be made, not just in your processes, but in also not just manufacturing processes, but also in management processes as well. And I have one example of what that looks like later on in slides. Okay, so aside from the benefits, why would you want to look at SPC in your food business? Well, there are a couple of good reasons, but one of them is because the standards that most of us now operate to, the certification standards, are now calling for you to do so. And they're doing that implicitly and, in an example I'll show you now in a moment, explicitly as well. So let's take the ISO 22000. The more recent revision of this standard is introducing this new plan, do, check, act cycle. So if you actually analyze what this particular approach is asking you to do, behind it ultimately is data and what you do with that data. Now, I'm not going to go into all the detail of this particular cycle, but I am going to draw your attention to this section called check. So the ISO 22K is now really saying very clearly that your processes must be monitored and the data that comes out of that must be used to conduct activities such as verification, and then you must report on the results. And SPC is a very powerful way of meeting this requirement if you are, in fact, ISO 22 certified. Now let's just take a quick look at the SQF standard, I should read. So for those of you guys who are SQF certified, you'll be aware in the latest edition that we have this new requirement, or the very explicit requirement 2.5.4.3. And this is really leaving you in little doubt of the fact that you must implement SPC as part of your food safety management system. So what it's saying is that you should use methods which are SPC based to effectively control and to improve or optimize your processes in relation to quality, food safety, and indeed waste. Now it goes on to say control charts should be used for this purpose, and they should have the ability to define the variation of your process and control it to plus or minus 3 standard deviations. Now we won't have time today to go into what all of these terms mean, but the point here really is that if you are indeed SQF certified, this is now a requirement. It's only one line, one requirement in the standard, but the resultant effort and work to meet that requirement is significant for most food businesses. Setting up SPC techniques in a company requires change, culture change, and indeed change in work practices. So today's discussion is a good way to get that discussion going and exploring some of the ways that you may be able to address these requirements. Just a few quick words about the father of SPC. Some of you may have already heard of this chap called Deming. Deming really was the pioneer of SPC techniques in the manufacturing industry. Following World War II, he became best known for assisting the Japanese manufacturing industry in rebuilding its economy and applying best practice for the manufacturing operations. It's generally recognized that the quality of Japanese products is among the best in the world. And this guy's efforts back then played no small part in that. So he was a strong advocate for using statistical techniques in manufacturing and reducing the variation of processes to produce better quality, more efficient operations. So it is on the shoulders of this individual really that a lot of what we'll talk about today has led to what us in the food industry having to in fact look at SPC as a tool in our manufacturing operations. I'm going to extract some quotes from Deming throughout the presentation just to put some context around it. And the first thing we're going to talk about is variation. I think we all understand what variation is, but let's just for a moment focus on what it means in terms of manufacturing processes. Some words from Deming. Uncontrolled variation is the enemy of quality. And this is the case. So every process, whether it's an engineering process or a food manufacturing process, has inherent in it the tendency for the process to deviate, and deviates around a central point. That point we usually call the mean or the average. So variation is there. We can't do anything about it, not that we want to. It's ubiquitous across nature. So whether we're talking about human height, weight, atmospheric temperatures, it doesn't really matter. The fact is that we recognize that variation is inherent in all of these things. And variation is also present in food manufacturing processes. Now that's okay. We're not overly concerned about that fact. But where variation is uncontrolled, or where we don't know what that level of variation is or the character of it, then that can lead to difficulties and problems. Distribution of the output from a production line, if it's unknown, will ultimately at some point in time lead to difficulties. So on the right there, we just have a simple graph. This is a representation of the typical distribution of results coming out of a process. Now, this could be anything. This could be temperature, the weight of your finished products, pH, doesn't matter. Typically, what you'll find in a normal process is a nice, clean, well-defined distribution curve, like what's on the screen there. Typically, this is called a normal distribution. The vast majority of the results will reside around the mean or center point. And then as we move out towards the tails, we'll see a diminishing number of results. And that's pretty good. That's a typical standard normal distribution curve for a process. So, understanding your process. So once we understand that deviation or variation around the center point is typical and it's normal, what we're then interested in is understanding the nature or character of that distribution. Lots of processes quite stable and no difficulties really in producing quality and safe products. But other processes may have perhaps more deviation than is desirable. So you need to understand or try to understand the character or the nature of those processes. And it all centers ultimately around data. And Deming's statement above, without data, you're just another person with an opinion. I think most people would agree with that. Opinions are fine if they're informed and experienced, but they don't beat good objective data. Now, most food businesses collect data every single day, and they collect volumes of it. So, for example, we collect typically data on the times, temperatures, pressures, pH, acidity, and so on, stuff coming off the processes itself. But then we also collect quite a significant amount of data relating to management processes like the outputs from audits, which can be in the form of a pass or a fail, or you may do some sort of rating. But it's all data. Non-conformances, another good example, the nature, the type, the criticality of those non-conformances, and the magnitude and quantities of them too. CCP monitoring data, virtually every food business globally will be producing CCP data. And also, for example, things like sanitation and cleaning, pass-fail results, recleans, the results from the ATP or total plate counts. So all of this data, which we're collecting and gathering every day, most food companies do it for a particular reason, and one is to demonstrate conformance and compliance, which is fine, and that has to be done. But the majority of businesses wouldn't use that data to drive improvements in their operation or to understand their processes. And that's where SPC comes in, because it's a missed opportunity. If you can collect this data, which you're doing already, but organize it in such a way that it will produce statistical analysis, that is the opportunity for most food companies to improve things, reduce issues, recalls, non-conformances, and just generally make the process a better environment for people to work in. Okay, so what exactly do we measure? Deming makes the point that it's impossible for you to manage what you don't measure. And I think, again, we would all agree with that general statement. Now, just because you can measure something doesn't necessarily mean you should. And that's particularly the case in food companies. I just make the point here that there is a virtually unlimited number of things that you could measure in your operation. And of course, you can't do that. So it's important that you understand how to go about identifying the correct things to measure as part of SPC. You don't need to do everything. Just important stuff is all you need to address. So we monitor in food safety for two reasons. One is compliance. I have to measure this because my customer says I have to. I think we're all used to that kind of environment. But we can also do it on the basis of risk as well. So I have to measure this because there is a significant risk attached to this process, this activity, or this management requirement. And this is reflected really in a lot of the food safety standards today. The standards recognize that this has to be the approach. There is there's no unlimited resources for us to check everything all the time. So a good example would be thermal treatment process to kill pathogens. Here we will identify minimum time and temperature, which is your limits. And it's necessary then to determine if at the set point, whatever that temperature and time may be, that the process that you're working with is in fact capable of achieving the required kill based on the variation in the process. And that's the key point. Single point measurements tell you what's happened at that moment in time only, but may not represent the actual distribution of all the results that will come from the process itself. So only by measuring and collecting sufficient quantities of data, analyzing it, can we fully understand whether processes are in fact capable of meeting the requirement. So using this data, the data you're collecting, guys, so what do you do with it? Well, you have a couple of options. You can simply use the single point data to determine whether or not the process or the test that you've just done meets specification. Now that's absolutely fine, and most companies do this. But then you also have a second option, which is to analyze that data using standard statistical techniques to answer a further question: does this process all of the time and consistently meet the specification? And there are two different questions. One is just simply a single point time check comparing against the spec, while the second one looks at using the data statistically to decide, is the process on a consistent basis meeting it all the time? And that's important, and that's where SPC is arguably more powerful than the sampling plans, test plans that we utilize today. But let's not kid ourselves. There are barriers to getting here, and SPC requires resources, and there is no argument about that. So the data, which needs to be collected and collated and organized, to do that you need tools, and tools can require time to set up and can require skills. So you do need people within your organization who understand SPC and are able to interpret the data, and that requires time, money, and resources. But let's say you are doing that. Let's say you identify some specific aspects of your operation, let's say, for example, CCP monitoring, where you want to utilize SPC tools. Then that information and data can help you describe your process. So I have a graphic on the chart, on the slide there, which has three different distribution curves. You remember previously we had that nice even distribution curve in the earlier slide. So that's typically what you should expect. That's normal. But by collecting your data, you may find that some of your curves don't quite reflect that. So you may have, processes which are tighter and which have a high capacity to meet the specification, but that might require a lot of investment, a lot of time that's unnecessary. And then you may have one with a very wide variation, in the black line here, which is completely incapable of meeting the standards. Okay, so again, with the data, you are getting a better insight, better understanding of the level of stability of your processes. Okay, the typical measure is plus or minus three standard deviations from the mean. And guys, what I'll suggest is that if you are getting into this area, you do need to do a little bit of research to understand exactly what is being spoken about here. Okay. This data can also throw up kind of certain biases or skews in your process data, and you may end up with sort of curves which have two peaks, or what's called bimodal, which show that there may be a shifting set point in your operation. Again, that kind of information is there, it's sitting in your data, but you need to extract this using SPC tools. Okay, so just want to illustrate the difference between taking the approach of, is it in specification, and the alternative question, is the process in control? So they're slightly different. So the out-of-spec approach basically sees you take single point samples, checking it, getting your result, and then comparing it against the specification for your product. You can plot those on a graph like this, which is perfectly fine. Okay, so this chart here is just simply telling us that the product is in specification based on a single point. But there may be variation around these test result points which is hidden, which you cannot see. So let's take a look at how the SPC approach differs. And this is an example of what you might get on an SPC approach. So you'll be taking your sample sizes, you'll be checking them as normal, you'll be getting an average, and you'll be plotting that average and the range of the results from the sample size. So this is now just telling you two things. It's telling you what the center point of your process is, but it's also telling you what the variation is, what the range of those results are. So based on the test that you do, it can give you a more intuitive and robust representation of the data from the point of view of control. Is the process in control? Is it operating within plus or minus 3 standard deviations based on the capability studies of the data being collected? So the point here, guys, really is that the data you're collecting at the moment, which is fine, if applied in a statistical manner, can give you a lot more insight, a lot more feedback, and a lot better reassurance that your process is in fact in control or is about to go out of control. So let's take a look at some of the standard tools that can be used in SPC. And the first one we're going to take a look at is capability studies. Now, a capability study is really about determining what the process character is. What is the variation in this process as it is? So this is an exercise which you could take, say, for example, a temperature related process. You will take a sample size over time, measure a lot of samples, and then you will effectively stack those results in the form of a histogram. And that will tell you a few things. It will tell you what the mean point of your process is, and it will also tell you the spread of the results. So you can see here we have our typical distribution curve, slightly skewed on one side, but it is giving us a measure of what the process is like at this moment in time. And from that, it is possible to develop your control limits, your warning limits, and your out of control limits. And it will also give a measure of the capability of the process against the specifications. So there's measures such as CP index and CPK. Again, guys, I won't go into defining these in this particular session today, but immediately it will tell you whether or not your process is capable of meeting the specifications, which is very useful. Okay, so that's capability studies. I'm going to show you an example towards the end of the presentation of how this capability study can be applied to a very specific requirement in food safety, which is quite useful. Now, some of the other common tools used are the control charts, and control charts can be used for both variable data and what we call attribute data. In this case, it's variable data. Now, variable data is a piece of data which you can measure accurately and numerically. So 12.5 degrees Celsius or 46 grams in weight. An attribute is the results of those kind of tests are more kind of it's good or bad, yes or no, or some sort of kind of qualitative expression of the output of the result. Excuse me. So control charts are very useful. There are many different types. I've just selected 3. The most commonly used are the X-bar chart. And so your X-bar chart is where you will take a sample size from your process, let's say the weight of your product. You take, let's say, 5 packs coming off the end of the line. You'll measure them and plot the average of the weights. Okay, that goes into the graph, and you can see the trend of where your set point is over time. The range chart, similarly, will take your 5 samples, and it will measure the difference between the highest reading and the lowest reading from the sample size, and that gives you a measure of your variation as well. Statistically, the tool can work out whether or not the process is shifted and is in control or out of control. Where you're not using a sample size of 2 or more, you're just simply using an individual sample, you can again also apply statistical techniques to that using the individual and moving range charts. So even if you are single point sampling, that's perfectly fine. There are statistical tools available that can be used and applied in those particular circumstances. The benefits of these tools, guys, is it gives a clear graphical representation of the state of your process in real time. And of course, if you're set up to do so, this can be alerted and actions can be taken. Set points can be adjusted, products can be put on hold, and that happens in real time based on science, essentially. For the attributes, so these are the results which give the yes or no, pass, fail type of outputs, or can be the number of defectives, for example, in a sample size. So they can be plotted using P or NP charts. That's the number or the percentage of defects per the sample tested. And again, they can be plotted, and your control limits, plus or minus 3 standard deviations, can be applied to these as well. Now, another area where statistical techniques can be used is for improvement, and I'm sure many of you have come across Pareto charts. And these are really useful for collecting large amounts of data and separating them out into what's important and what's not. So typically, a Pareto charts, let's say, for example, we're looking at overdue audits here, for example. This particular chart is analyzing the total number of overdue audits and separating out which of those audit programs are contributing most to the workload. So you can see here in this particular example, some daily test is the vast majority, and then descending down to the smallest contributor. Humans, as I've said before, are capable of fantastic accomplishments. Sorting and analyzing and interpreting large amounts of unstructured data is not one of our strong points. And Pareto is a very effective way of doing that. Now, the issue here, of course, guys, is the time and effort to do this. If you do want to use Pareto analysis, then you have to, by definition, have a system to literally collate, analyze, and present the data back to you in some way. But Pareto analysis is a very good one. Very often used in relation to customer complaints and analyzing any trends which might be emerging. Okay, so now let's just move on to some examples of how SPC can be used in the food industry. I have 3 examples. The first of them is CCP Control. I think this is the one that we'll all relate to best. Okay, so many of you will have in your processes a number of CCPs, at least one, perhaps more. And in many cases, I think a lot of companies will have a monitoring program. They'll test, they'll check, they'll inspect at a defined frequency. And then they'll simply record the result against the critical limit. Now that is, again, as I say, is perfectly fine. However, with the application of a control chart, you can really become a lot more sophisticated around controlling that CCP, because that CCP will have inherent in it some sort of variation around the mean point. So at the very least, you would want to know the capability of that process to meet the critical limits. And single point testing is probably not the most reliable way of doing it, albeit if that's what you're doing, that's fine. So in this particular example, we're looking at a temperature, let's say 10 degrees C, and we have some critical limits here. We test the process. In other words, we take temperature checks on a scheduled basis. Now with SPC, what it's doing is it's collecting those results and plotting them over time. And it's also building and updating the distribution graph as well. So it's telling us what the capability of the CCP is, not just at the point, this moment in time, but also based on the overall trend of the process. So in this particular graph on the right, we see a control chart, and one of the rules you can introduce is that if you have a sequence of results, let's say 7, consistently above or below the mean point, then you can have a rule that an adjustment must be made, because it's likely that the process is drifting towards one of the warning limits or the action limits that you may have. So this can trigger an adjustment or change in your process before the out of control condition is met. Something you can't do with single point testing or the traditional sampling approach. And again, the system with SPC should produce for you a CPK and CP index, which will give you an immediate result, whether it's in or out of control. So that's really very useful, particularly for CCPs. And my advice to food companies who are just embarking on the journey of SPC implementation is certainly consider the CCPs as your first point for implementing SPC techniques, because it's where you're going to get the maximum value. Now, there may, of course, be other opportunities in terms of efficiency and quality. That's absolutely fine as well. But the CCPs is an easy win, I think, with SPC techniques, and definitely should be considered as one of the first areas to explore. Now, the second example is in relation to Pareto. We just mentioned them there. In this example, I'm just taking corrective actions. So guys, corrective actions, as we know, is one of those more difficult aspects of your system to manage, particularly in relation to the quantities, the numbers of corrective actions being produced, and where they're coming from as well. So in this particular example, you can see we have a Pareto chart for corrective actions by source. So we can see the areas of your management system where corrective actions are originating and coming from. In this case, we have auditing, supply chain management. These are just generic labels, guys, but you get the picture. So what we can conclude from this is that the vast majority of our corrective actions are arising from, say, the audit process. So that's perfectly fine, but it does lead to another question. Well, what exactly in the auditing programs which auditing programs are creating that body of work? But the point here is with Pareto analysis, we're in the position to now ask that question. Okay, so we know auditing is the main contributor. Let's take a look at auditing. What's going on there? And we can drill down further, again using Pareto analysis to identify that it's a daily hygiene inspection that's contributing to most of the the corrective actions that are being created. So there would be likely something happening here, frequent failures of this particular daily hygiene inspection. Now that gives the team an opportunity now to focus some of their energy on one particular aspect of the food safety management system. It will be well worth investing a little bit of time in seeing what's going on with the daily hygiene inspection in this particular case. Now, without Pareto analysis, it would be very difficult to get that level of insight into your operation and business. And again, it does require time to collate the information and data, but there are tools available to assist in that. Okay. So I think most companies would view this as a very beneficial exercise if you are a business who's proactively looking for areas to improve your operations. Now, the final example, example 3, is the validation of cleaning and sanitizing methods. So this is a slightly unusual one, but I think many of you who are involved in managing sanitation programs will probably appreciate this. So let me just summarize it. I'm not going to go through all this detail. So guys, most of you will, by law or by the requirements of your customers, will need to clean your factory and operations. Now, you do that for a very simple reason, is you need to manage certain hazards like pathogens, like say residual chemicals or allergens, for example, and they need to be removed and they need to be managed and controlled. So cleaning and sanitizing is the process, is the system that we use to do that. And that's fine. I think we all understand that. However, simply creating a cleaning procedure or a program to, let's say, remove allergens, for example, is in itself not enough. That must be, in a lot of cases, validated. So when we say validation, what we're saying is the method as we've defined and documented it, and as we carry it out, is it in fact, in reality, capable of removing those particular allergens between production runs? So that could be a typical question that's asked. Okay, so you do, of course, have the option to put together an approach which will be just simply to do the cleaning and then take a few swabs. If they're clear, all is good. But again, for high-risk operations, it's not sufficient. And most companies need to do a validation process of the cleaning method. Now, I've just summarized an approach for validation for cleaning here on the right, guys. So typically what you would do is you would set up a document cleaning procedure. You would document the procedure, train your employees up, get the equipment together, and then conduct the cleaning. And yes, of course, then you will do some samples and testing afterwards for ATP. You might do some plating, allergen testing, check for residual chemicals. It doesn't really matter which one you're focused on. The point is that you conduct some sort of testing afterwards to check if the cleaning method is in fact good enough to achieve the results. Now with SPC, you can take this to a slightly different level. So rather than just simply recording the output from a particular test, you can enter into a capability kind of tool like this, the results over time. Okay, so for example, in this case, it could be ATP results, and you can enter the RLU values in here, so 50, 60, and so on, and collect that data over time. And this will build out our famous distribution curve for that particular sanitation program. And of course, we would expect that the distribution on the graph will lie within the limits which are highlighted here in yellow. This tool, by the way, guys, this tool is in Excel. It's available free from our website, so please feel free to go to resources and download it, and you can use it. It is quite a useful tool, particularly for high-risk operations that need to show validation of cleaning. So you're not just proving that the cleaning procedure is capable of passing a swab today, you're also proving, using this particular statistical tool, that it's capable of meeting the requirements all the time and over an extended period of time. So the approach you can take is if it's a new cleaning procedure, you document it, you train people up, you conduct the training as documented, or conduct the cleaning as documented, take your swabs over time, significant sample size is important, and then you can see immediately whether this procedure is good enough. If it isn't, you just modify the procedure, repeat the process again until you get a validated cleaning procedure. This is something which any auditor, I think, would be delighted to see, and which the business itself will be happy to know that they've fully validated the cleaning. So just this is an example of the register of results. And here's our finished distribution graph with our CPK reading here. In this case, in this example, the CPK is not within limits. You can see we have a few tails hanging over. And it's telling us, look, this is not a validated cleaning procedure. Go back, look at it, change the procedure, and repeat the process as well. Okay. So that's if you want to log on to Safety 360 free resources, just take a look at tools. And there's a white paper to go with this validation cleaning procedure, which will help you actually use this tool as well. Okay, as I say, guys, that's free, and please do download it and see if it's of much value to you. Okay, so that's 3 examples of how SPC can be applied. Simon, that's the presentation, and more than happy to take some questions now.
Yeah, thanks very much for that, George.
No problem.
Nice of you, and we'll no doubt help the audience. If you want to, I'll stop sharing the slides. If you're going to switch your webcam on, please. Right. So, let's have a look. Any questions for George? Sarah, we've got one from Sarah there. Can you start, George? How would you perform SPC on pass-fail data?
On pass-fail data?
Pass-fail.
Pass-fail data. Yeah, so in that case, you would use there's a specific charts and tools like your P or NP charts, which allow you to express that kind of qualitative result. A pass-fail, go, no-go type of result. Yeah. So there are specific charts for that. Yeah.
Okay, and Andy Keller was asking, saying, I like this validation tool. Could we download this? Is that at the download that you gave the link?
Yeah, so if you just go on to Safe Foods, free resources, and just search through that, you'll see the tools that are available. What we could do, Simon, is attach it to your follow-up email. Yeah.
I will, yeah. I'll include a link to that resources page in the follow-up. I'll do exactly that, yeah. Any questions for George while he is here? We're getting some nice comments, nice presentation, George, very nice presentation. Here we go. Got one here. Let me see. G. Nagalingam, how product yield can be depicted in a better way?
Product yield. Well, I mean, it really depends on the situation. Yield is typically expressed as a percentage of the total input versus the output. So, yeah, I mean, that could be done. Yeah, it would just require a little bit more thinking, a bit more information to figure that out. Yeah.
Okay. Banji, what's the least number of data you need to perform SPC?
Okay. Well, look, I mean, again, it really varies depending on the application and the use. So for capability studies, you need a relatively significant amount of data, but that depends, again, on the concrete situation. Yeah. But it is possible just with single point data to do statistical analysis too. There are tools for that. Yeah.
Okay, and thanks, Elisa. She's put the link in the sidebar to the page on Safe 360 website.
Perfect.
Alison, what would be the best way to implement SPC in a plant that runs multiple products with different specifications per day?
Yeah, well, just in general, the advice I would give is, start tentatively. Don't rush into a massive project putting SPC on everything that moves in your operation. So I would start with, maybe one particular line where the high-risk products are produced, and maybe start there and as a pilot, see how it works out and see can it be extended across the rest of the operation. But take it step by step. Yeah.
Okay, Tristan, do these tools you provided go over the mathematical side of statistical analysis for those of us who haven't been in a statistics class for a few years and need a refresher?
No, they don't. The tool itself will have the formula built in, so you can click on the cell and see the formula. But there is quite a lot of free material on the internet on SPC, and I would suggest maybe go there and look for it.
Okay. Ionis, if we build a control chart that's out of control, can we remove the out of control points to redefine parameters like mean? If yes, how much should we remove?
I don't really understand that question. If you have an out of control point in a control chart, I think that it is what it is. I'm not sure why you would want to remove it.
Yeah, unless it was sort of data pollution that was way out of specification and you could genuinely ignore it. But
yeah, like an outlier. I mean, that can happen. But again, that's say where companies that are introducing SPC, they would need to have somebody proficient in the organization who can interpret the data and make that call, essentially. If that is it's a random event, it's not typical of the process.
Yeah.
Yeah.
Sandra, would Safe 360 software be any use in the data analysis of food safety? And is the software available in Spanish, Portuguese, and Polish?
Okay, so we have just recently introduced inbuilt SPC tools into our products, and we'll continue that build out over the course of this year. Yeah.
Well, there you go. Presentation is very good. Thank you, Tina. Any more questions for George? We have got a few minutes. We can take a few more questions if you do have one. Okay, Patricia, what would be the best number of measures to run a validation?
Well, again, I think you'd probably be looking at maybe 20 for a cleaning process, maybe around 20 specific results. Will probably start to give you a significant set of data to validate. Yeah. But again, it depends. You need to design these around the actual concrete situation on the ground, and a little bit of expertise and advice and input can help there.
Yeah. Frederico, yes, we are recording today, and afterwards we'll send the recording slides and also the links to the resources on Safety 360. So you'll have lots of time at your leisure to go through the video recording with the presentation in your hand, and then further investigation at Safety 360, and then just like George said, take it easy, pick something and give it a go. Yes, as I've just mentioned, we'll be sharing everything. George, Tina says, George, some say 40 data points is fine. Is this correct?
Again, it depends. It depends really on the situation. I mean, in some cases, you'll probably sample that within a day. Other companies, it might take a bit longer.
Okay. And Barbara, may I ask you, what is the difference between the software you propose and Minitab?
Minitab. I don't know what Minitab is.
It's a very comprehensive SPC program, Minitab.
Yeah.
For most people, it's probably way too overblown. Teresa Dunkley Verhage, what qualifications deem someone to be qualified to interpret SPC data? Do any standards define this?
I mean, there are programs that you can undertake to become skilled in SPC. I mean, there's the whole Six Sigma type of approach. They have the black belt and all that kind of approach. So, I mean, that's one option. Again, I would suggest that maybe some external training provider coming in and giving a good, training session for a couple of days probably will be enough to get you started.
Okay, just a comment from Shiva, who's an advocate of Minitab. It's one of the best tools that I have come across. To be fair, I've not really got any real experience of it. But yeah, okay, Shiva. Mohammed, what about data transformation for statistical analysis?
Okay.
Do you understand that question, George?
Not really, no. Maybe if she can just provide a little bit more information.
Yeah, just add to that, Mohammed, if you can. What do you mean?
Maybe the data transfer, maybe, is it? Or?
What about data? Yeah, possibly.
Transfer and all. Yeah. So yeah, I mean, in the context of our products, we can do that. Yeah.
Right, I see. Questions? Got 6.5 minutes. Anybody? Yeah, just to remind you again, it is being recorded, and we will send the recording slides, etc., and the links to the resources that we've mentioned. Shiva, further comment on Minitab is widely used industry to understand and carry out process capability studies and statistical analysis. Just add to that, Shiva, is it user friendly? Is it easy to get into? Can you just get started with it, or do you need to go on a degree course? Jeffrey, I would offer that Minitab is a statistical analysis program. Safety 360 has a wider scope of applications that can be used in food processing operation. Any books you would recommend? Melanie asks, George. Have you read any good SPC books lately?
Yeah, so what I'll do is I'll send you over a couple of titles, which are probably good to get started on. And you can include those in the email, Simon.
I was sort of joking then when I said, have you read any good SPC books? But you have. Okay.
I don't get out that much these days.
Jean Nagalingam, This less than 3 standard deviations can be applied for all process attributes.
Yeah, well, it depends on your appetite for control, but typically plus or minus 3 standard deviations is a measure of a process that's stable and in control. So you typically set your warning limits around that and your action limits around the plus or minus 4 standard deviations.
Okay, and Shiva, I don't know if you're a salesman for Minitab, but saying it's very, very user friendly. No, we'll take your word for that, Shiva. So look up Minitab. Sandra, thank you, George. It was awesome. Like your lectures, like your lecturers. Yeah. Thanks to you for attending, Ezra, as well. Thanks to you all for attending today. You know, it's great getting the presentation and getting the information from like George, the speaker, but having your input, you know, and the questions, cherry on the cake, really. Any questions, or should we wrap up? Yes, Tina, we do have a webinar for Pareto Principle. In fact, Vladimir Sachinsky did a webinar. It was a paid one, $97, root cause analysis and continual improvement, and it did cover Pareto Principle and various tools like FMEA and things like that. So there is one on the website. Yeah, okay then. Yeah, thanks very much, George. It's been a pleasure. It's been great having you, and superb resources and lots of great tools for the audience to take away and use in their businesses. No problem, Simon. Yeah, thank you. Okay, see you again soon, George. Cheers. Okay, cheers. Bye-bye. Okay, that was George Howler from Safe Food 360. I did load in the sidebar the next free webinar we've got coming up on June the 28th is tips for an effective environmental monitoring program. Lots of questions come up about this on the discussion forums. How do I develop an EMP program, etc. And that's with Dr. Douglas Marshall from Eurofins Food Safety Systems, Dr. Douglas Marshall. So I'm sure that will be very insightful as well. The only thing I've got to do now, I'm going to remove that from the sidebar because I need to load the certificate of attendance. I'll just put my teeth back in. So I've put in the sidebar the certificate of attendance. Click the download now button. That'll open Dropbox. You can download it. It's an image file. You can either print and sign it or open that image in an image editing software and then type your name. I think Donald Trump's gone home now, so yeah, I probably missed the boat with that one. I'm up in sunny Manchester. They're down in London, all the big wigs. Okay, so it's been great having you with us. Thanks again to George. We really appreciate your attendance and getting involved with the discussion. So keep coming to these webinars. And I did load before. In fact, I'll load it again now. We have compiled all of the previous food safety. Oh, it's gone. Ah, well, I'll load it next time. All 120 webinars now in an Excel. You can save that to your desktop. Click on a link, takes you to the webinar. So whenever you're doing nothing at work, you can just browse through and watch different subjects at your leisure. Right, that's it. Have a nice weekend. Enjoy the rest of your Friday, and we'll see you on the next one. Take care, everyone. Bye.